Hello everyone, my name is Barrick and today I'm going to be showing off the first demonstration video of the next prototype for my artificial intelligence that I call IRIS. I've given up on the first prototype. I believe it got about as far as it was able to go. Its inputs were based on a customized API, essentially, that the game engine was feeding it information about the game world. And that is good, but limited to only that particular game environment. So I wanted something that was a lot more general purpose and that I could eventually apply to other problems outside of just the little game environment that I've thrown together for it to try in. And this new environment, as you can see here, on the left is the game world, and on the right is how Iris sees this game world. So Iris is now operating on a per pixel, simplified per pixel inputs. And I say simplified because each pixel is a 32 by 32 block instead of being on an exact pixel, just because I don't have the hardware to run it on an actual per pixel uh, thing and have it function in any reasonable amount of time. So to demonstrate what Iris is currently capable of, um, I'm going to be playing the game, and Iris is essentially going to be watching me play the game. The goal is for the little robot character to collect the batteries that are on the screen, and you can move in an up, down, left, right fashion. Right now, it's a clean slate. There's no information that Iris has about how the game works or how anything will change on the screen. The things that Iris can see are the inputs that I give it. So if I push left, will understand that I'm telling it to go left, and it will perform that action and observe the results of that action and then remember that. And so as I make it move around, it will be able to accurately predict what is going to occur every time that it makes a movement. It's not currently capable of having its own goals or making its own plans or moving on its own yet. That's still in development. This is a pretty early stage for this, but it's at the point now where it can observe the environment, make predictions, and understand what's going on. So let me just do a quick demonstration of that real quick. We're going to tell it to move left. Now right now it's trying to model the action of moving left, but it has no information, so there's no change that you'll see on the screen on the right there. And then I'm going to tell it to go, and it moves left. And there was an unexpected result, as it says here, and its plan was interrupted because there was of an unexpected result that the character moved left. Now, if I tell it to move left again, it will think, okay, so this blue square, or on our side, the robot, will move left every time that I push the left command. And I can give it more than one command in a row and then have it perform those commands, and it will follow along and observe each one of those commands. So I can give it like a plan of action to perform, and it'll watch and see what happens when those actions are performed. So let's at least tell it how it moves around in the world. So I just told it to move right, so now it can understand that moving right moves right, and if I move left, it'll move left. And so it's modeling what it's expecting the game world to be based on the inputs that I'm giving it and the plan as it follows through. And we'll do an up so it can understand moving up, and we'll do it a down so that it can understand moving down. Now, just from that very small set of training data, it understands that these four commands make the blue square essentially move around on the screen, and I can have it follow whatever pattern I want it to follow just by the movements. Now, of course, this is a pretty easy puzzle game if this was all there was. There's just the batteries to collect and a little wall in the middle that is very easy to avoid. But it doesn't understand any of those interactions yet. So, for example, if I was to walk up to the wall right now, if I told it to walk up to the wall, it doesn't know what's going to happen. It suspects that it's going to go inside the wall, but of course, that's not what happens. So it says, okay, well, this was a different thing than what happened before. And I was expecting to move to the right, and I didn't move to the right. That's kind of interesting. And it makes note of that. And now if I tell it to move left, move right, and then move right again, it recognizes the fact that there's a wall in the way and that it can't move through a wall in that direction. But that doesn't necessarily mean that it quite grasps the concept, and you'll see here why. So if I tell it to move down, and then tell it to move right, and then tell it to move up, it'll still think that it can move into the wall, because moving right is a different action than moving up, and it doesn't know that moving up has effectively the same result against the wall as moving right against the wall. And so if we do this, we can teach it that moving against a wall will prevent it from actually moving in that direction. And here's an interesting thing right here. Because it hasn't had enough information about all of the interactions in the world yet, it's not perfectly observing everything. So it thinks that the wall is going to prevent it from moving to the left, even though the wall's not actually in the way. And that is a prediction that obviously was wrong. And it notices that that prediction was wrong, makes note of that, remembers that, so that next time, if I was to circle back around, it will understand, okay, well, I was wrong. I can actually move it to the left, even though the wall is right below me, and that won't affect anything. And it's the same kind of a situation for the batteries. It doesn't have any knowledge of what will happen when we move over and collect a battery. And so it will go over there and attempt to collect the battery. And it will do so and recognize that when it collects the battery goes away. And it is able to move where the battery is. So now, if I was to tell it to go down and collect this one, you see, it recognizes, okay, when I move left against the battery, I can collect the battery. And it's the same thing as with the wall, that if it moves in a different direction, it doesn't quite understand that that's what's causing the battery to go away and it to collect it. So it's another teaching moment that we'll have here in a second when it wanders itself down there and moves against the battery, collects the battery from a different direction. Right now, it doesn't have a way of, I guess you could call it free association, of saying, okay, since I can't move left, well, maybe I can't move up against the same thing. But that's something that I'm going to see if I can't implement into it here, or if that's might actually be something that it's just going to have to learn on its own. We'll have to see with some more development. All right, so let's go over here and we'll collect this battery real quick. And it'll wander over and collect that battery. And then we'll collect the other two batteries and move on to the next level. And the next level is a little bit more complicated. It's got a lot more walls, but it's not super complicated again. It's something that's very simple for anybody to be able to, I guess you could say, complete, whatever you want to call it. All right, so it's going to go collect this one, and then you can notice that it's running just a little bit slower than it was when it first started, because it's having to analyze things a lot more whenever it makes an action and look and say, okay, there's more things that can occur when I move rather than just freely moving around the world. So I have to look at all these different things and see the similarities between when I can or can't perform an action based on its memory of performing that action. All right, so it's going to go up here, collect this battery, and we're going to go on to the next level. And it doesn't fully grasp walls yet because it has only interacted with one wall. And so when there's a multitude of walls, it's not sure exactly what's going to happen whenever it moves. And it thinks, okay, well, maybe I can move through these walls because there's so many of them. It's a big difference from just the singular wall that it had interacted with before. And eventually, after trying a few walls and messing around with it, it will understand that, okay, well, a wall is a wall, and when I try and move against it, that's not going to happen. And so it's just a matter of increasing the amount of data that it has, increasing the amount of training it has. And after we go through and oh, see, there was an interesting little thing that it had. Let's watch that. So it thinks that when it moves to the right past this wall, there was a little bit of a, yeah, you can see there where, and I can switch his view to our view too. See if I can switch it to there. It thinks that it will multiply itself instead of just moving correctly to the right. And again, that's something that's a matter of looking at, it's basing everything on these pixel information and changing the environment based on pixel information. And as it gets more data and explores more and wanders around in its little world, it will get a more and more accurate world model that it's able to understand how the world will work based on the actions that it's going to perform. Now, the really cool thing about this, and I'll show you that here in just a second, is that based on just using its world model of what it's observed and what it's understood about what's going on in the world, we can effectively play the game in its mind just by performing the different actions or telling it to perform the actions, setting out a plan for it to perform. We can tell it, okay, we'll go over here, then go down here, collect that, go over here, collect that, go over here. Let's go back. We'll collect this first, and then we'll go and collect that. And so effectively, we're playing the game in its mind and then letting it perform that plan and what it's thinking of and expecting the world model or the world to do based on its own experiences. So once it has enough training data and it's been exposed to enough things and played through the game or whatever you want to call it, you can play in its head the game just as if you were playing the game on the left side of the screen and actually following through and playing it. It's kind of a neat little thing to mess around with, and I've actually spent more time playing around with that than I should have just playing around with it instead of doing more programming on it, because it's kind of fun to just mess around with and see the different things that it's expecting the world to do. And sometimes, like you saw earlier with the duplication of the robot, that it doesn't quite grasp exactly what's going on in the world yet, but every time that there is a moment where there's an error and it doesn't understand what's going on in the world, it uses that moment as a teaching moment to train itself and have a better understanding of the world so that next time when it models what's going to happen, it produces a much more accurate model and is able to, well, will be able to make more accurate plans and better plans to achieve its goals. So I think that that's pretty much all that we're going to go for today. I'll let it complete this and go into the next level just for demonstration purposes. But this is currently where IRIS, I guess you could call it IRIS 2.0 or the IRIS Prototype Beta, is sitting. Like I said, there's still a lot of work I have to do. It doesn't have its own goals. It doesn't have its own planning capabilities. It can't perform actions on its own. But it is very good at observation and being taught how the world works based on observing a human, in this case me, play the game world and watch and see how the game world's going to work. And then when it's planning and able to do things, it will be able to use that information or come up with information entirely on its own, depending on if I want to leave it as a clean slate and let it explore and figure all this stuff out on its own. So it should be some very interesting developments here coming up soon. I'm going to keep working on this, of course. I've got quite a bit of plans and quite a bit to do yet, but well, hopefully all goes well and nice and smoothly, and I'm able to put out some pretty cool videos in the next couple months and show this thing working pretty well. The big thing for me is, of course, switching Iris's inputs into pixel inputs, just raw pixel data, because that makes it so much more open to any kind of testing environment that I want to throw it against. Should be able to pit this against like the Open AI Gym environments and test some of their things out with it. Pretty much anything. Of course, OpenAI just came out with the no Open Universe, I think it's called, where it basically is interacting with a web browser, and that would be kind of interesting to see and see it perform its various actions and do different things inside there. So we'll see. There are some really cool things that I'm planning for this, and like I said, hopefully in the next couple of months, I'll make some great progress and be able to put out some more videos. Until next time, I will see you guys.